Hey everybody, how's it going? John here, and I'm bringing you another solely coded video. And today I thought I would give you my 3 tips on keeping your code base clean. This subject matter is something that you don't really have to deal with when you're programming on your own. Most of the time you work on a few projects at a time for a few weeks and then you end up throwing them away. So this whole concept of like tech debt and code rot doesn't happen when you're working on your own. On that same vein, I thought I would kind of clean up this studio a little bit. I've been at this new home for quite some time, but I just haven't had time to set up the new studio space, and today I have some time. So it looks pretty clean from here, but if you zoom out and take a look, this is like the only clean area, and everywhere else is pretty messy. If you can see, I just have my Oculus and all this random stuff. It's everywhere, just a bunch of stuff everywhere. So even this room I'll probably try to clean a little bit. So yeah, so that's kind of what I'm planning to do today, and as I clean I'll kind of give you guys these talking points. Much better. So let me know what you guys think about the kind of the setting that I have going on the background. Leave your comments below. Let's go to our first tip. So tip number 1 is to try your best to not make tech debt. For those of you guys don't know what tech debt is, whenever you're working on kind of like a large software engineering project, it happens with every project, but it's basically something that is important, but for whatever reason, it doesn't get prioritized to do. So that's what tech debt is. And there are a lot of types of tech debt, like different types of tech debt. And the one that I'm going to be focusing on is things that you can avoid. An example of something that you can avoid is, let's say that your organization all of a sudden created all these new kind of regulations. Like all of your projects has to eventually get onto this like new pipeline or something, or add telemetry to all of your services or something like that. That is kind of like tech debt, but it's not really. It's something that you have to do eventually. So it could be kind of considered tech debt, but it really isn't. The type of tech debt that I really want to address is things that you can avoid. And it usually has to do with the way you program and the way you code. A good example of this is, let's say that you have some business logic inside of your code, and it works perfectly fine, and it's inside your like one large function, and everything works and everything is just great. No one's complaining or anything. But let's say later down the line you have to start adding to this code base, and instead of reusing some functionality that can be reused, you just kind of willy-nilly add more to this one large function. So that's something where that's like kind of a bad anti-pattern, where you're not using a principle called like dry, which is don't repeat yourself. So that's an example where you could take something that can be reused and you decide not to reuse it because you're either lazy or for whatever reasons. So that's an example of something that can turn into tech debt. You'll often hear this when you're working in the field, where someone will say, we'll just fix that later. So when you hear someone say that, really think about, is it something that we're going to do later? And if it's not, then maybe you should just fix it right now anyways. One good thing about having this kind of mindset of trying not to create tech debt, and what happens is, if you kind of follow good practices and try to be clean and modular with your code base to start with, later on when you're adding new things, you have so much velocity. It's so much easier to work with your code base. It's so much easier to understand because everything is clean and everything is where it should be. So yeah, that's just like tip number 1. You should really think about this kind of concept of trying your best to be clean from the get-go. Don't just name random variables saying that you'll change the variable's name later after you figure out the logic. Just take your time, name things properly. Spending a good amount of time thinking about the names to your variables is very important as well. So all these kind of like larger coding practices all kind of tie into cleanliness, and then ultimately preventing tech debt to happen in the first place. So yeah, that's tip number 1. So I have this like really old iron. I have to like clean this thing. Is this like wall drop? I think I'm just gonna get rid of this. So tip number 2 is, when you see something, do something. And what this really means is, let's say that you're coding and making like a new feature or something, like you land on some file where there's obviously things wrong about this code. Like there's a bunch of variables not being used, there's like stylistically like something that doesn't fit to something that you guys agreed upon recently, or maybe it's you guys switched over to TypeScript and it's still just like a JavaScript file or something like that. There's all these like kind of things where over time, when your projects evolve, some things get left behind because they ultimately still work, but in the grand scheme of things, they don't, like, that kind of code doesn't really belong in your code base. So when you see something, do something about it. Obviously don't go and refactor the whole thing without telling anyone. Not because that's like a bad thing to do. You should refactor things if you see like major issues. But usually when you're assigned a story or a feature to finish, there's some kind of estimation that's done beforehand. You say, this is going to take X amount of points, and that kind of equates to X amount of days usually for this type of work to be finished. But if you start going and cleaning up all of this like stuff and a bad like code rot that's already there, then it's going to take you a lot longer time to do it. And I'm not saying don't do that, but when you see something that's easy to fix and when you see obvious things, go ahead and clean it up. It could be a comment, and it could be like an old comment that doesn't like really apply to the business logic that was commenting. That's like a very common thing where people forget to delete the comment. Maybe it's some unused variables, maybe it's a stylistic change, or maybe someone using like an old version of a service or something, and you just happen to, and it still happens to work, and so you just bump that up. Like all these little things over time add up to like a huge amount of work. So be a good citizen. When you see something, do something about it. That's tip number 2. So I'm taking a quick break from cleaning. So the final tip that I have for you guys is get good at refactoring. And the thing is, refactoring can be very daunting. When you're first starting out, it's this thing where if you have a piece of code that's working, you really don't want to touch it. That's how it was for me when I was first starting out. I had this like piece of code, it was working, it took me forever to like figure out the like all the bits and like edge cases and all these things, and it took forever for me to get this thing in the first place. So I'm like, why should I refactor this? But over time, when you get better, when you start thinking about optimization, runtime, space time, all these things that you as an engineer, you should really think about. You start to see anti-patterns everywhere. It's not that like people suck or anything. It's even yourself, right? Over time, you get better as an engineer, and your code a year from now should be much better than the code that you're writing now. So just by that simple fact, the code that you write now probably sucks comparison to the code that you write later. So you got to get good at refactoring. Now there's some good strategies on getting better at refactoring, and I would say the number 1 tip for good refactor practices is to write unit tests. So if you write really, really good unit tests that cover all the edge cases, then all you have to do is make your test pass again, and you've successfully refactored your code, right? So that's actually one of the main beauties of writing tests. Like writing tests, it's good to know that your code is working, but the real power of writing good unit tests comes from the ability to refactor safely, right? Because you could delete the entire thing and all your tests will fail, but once you slowly get each of those test cases to pass one by one, then you know that your code will just work. Also, another good skill to know is version control. If you version control properly, and if you're not afraid of version control, then you could just check out a branch, do whatever the heck you want with that branch, and try some crazy stuff. Try these massive changes and see if it all works. Because sometimes when you're refactoring, you might think something might work, but you need to have that practice of trying something new and trying to refactor to see if it will actually work or not. But yeah, so that's like my final tip. Don't be afraid of large refactors. I hope you guys liked this quick video. I didn't really do that much cleaning. I got tired halfway through and I kind of need to do other stuff. So I'll get back to cleaning that place eventually. I only just reset up my studio a little bit so I could record these videos a little bit faster. Oh yeah, I also been under the weather, and that's why haven't been uploading as much lately. But yeah, I hope you guys enjoyed this quick video, and I'll see you guys on the next one. Bye.